Okay, this is a video for the perfect squares and square roots. This is, and then on the other page is perfect cubes and cube roots. Well, so on your Canvas page, print this out or listen to what I'm saying, and then you can take a screenshot of this. So what a perfect square is. A perfect square, and I listed this out for 16, like the factors of 16. This is saying 4 squared, 4 times itself, so 4 times 4. The reason these numbers are called square numbers or perfect squares is because if you took the factors of 16, 1 times 16, 2 times 8, 4 times 4, you can make a perfect square out of this 4 by 4. The 1 by 16 you can't, 2 by 8 you can't. So these numbers are called perfect squares. Now the number 8. The number 8 is not on this list because that's 1 times 8, 2 times 4. You can't make a perfect square as an array. There's like a 1 by 8, a 2 by 4. You make rectangles. You can't make a perfect square. So these are not perfect squares. You can write down this information. So 5 squared is 25. 6 squared is 36. We talked about buttons on your calculators. So the square key, we talked about that in class today. So the x squared key, okay, that you can do 6x squared and equals. Now Casios, look for an x square. I think it's up here somewhere on the Casios. If you're on your state test, if you're using an iPhone, turn your phone and it'll come up on the calculator. Okay, so you can take a screenshot of this. These are your perfect squares. Square roots, they undo the squaring. So these, and if you look across, like this is the same, these are the same numbers that are over here. So 1, 4, 9. But this is a reference sheet because I want you guys to keep this, and you're going to turn this in, a photo of this. And I know it's my own work, but I want you to have it on your computer so then you can refer back to it. Okay? So you can take a screenshot or go ahead and pause this and then write these down. This is going to go in order 1 to 25. I just want you to be up 17, like if you need to reference this. Now, the second page. So pause this if you're writing that down. Second page talks about perfect cubes. Well, what a perfect cube is, it's like a die. This is a cube. It's called a cube because all 3 dimensions have the same length. It's the height, the width, the length, they're all the same measurement. So we can call it a cube. So 1 cube means 1 times 1 times 1 is 1. This is repeated multiplication. Exponents are repeated multiplication. Okay? So 1, 8, 27. So these are perfect cubes. Then here we have the cube root. Okay? The cube root. Now you have a little 3 here. We're going to talk about this down here, what these are called. So this 3, so this is why we can't always call that symbol a square root because you're not always taking the square root. So you have a 3 here in this part. This is called the index. I'll go ahead and ruin the surprise for you. And then right here's the same thing, 1 through 10. So the cube root of 512, you're looking for what number times itself 3 times, it gives you 8. It is not 512 divided by 3. No, it is not that. It's looking for a number times itself 3 times, it gives you 8. Then, again, pause this and write this down if you'd like, or you're going to be able to take a snapshot. These are common powers of 2. And then we talked about the game 2048, because when we did 2, 4, 8, 16, and then 2 to the 11th power is 2048, and we talked about that game a little bit. Here are 3, or maybe like 4 important keys. If you needed to do 2 to the 7th, and you don't want to have to sit there and go 2 times 2 times 2 times 2, use your caret. This is called a caret key. Or some calculators have a y to the x or the x to the y, or to this a box. Which means you can do 2 caret 7, that's like computer programming, equals. They'll give you 128. So anytime you need to know the power of something, or take it to the exponent, 2 xy 7. So it all depends on your calculator that you're using, your key. So it's important to know how to use it. Okay, so you can write that. Common powers of 3, 3, 9, 27, 81, 243. It's just good bits. Now, terminology. So this symbol here, a lot of people call it the square root sign, but it's actually called a radical. It's a radical sign. because you can't always say square root because you might have a third root. You might have the fourth root. Like the fourth root of 81 is going to be 3. That you're looking for what number times itself 4 times. So we can't always call it a square root. So we call it a radical sign. The number inside is called a radican, R-A-D-I-C. The number on the outside tells us what power or what root we're taking, and that's called an index. Now down here, when you see the radical sign in here, that means it's 2. That you can call it the square root. If there's nothing in front, your answer is just going to be the positive root is 5. If there's something in the front, like this positive and negative, that looks like a plus minus. What that means, because 5, not only gives you 25, means is you are going to have, you're going to have a negative 5 times negative 5, which that can also be 25. But that means you need the positive and negative root. Okay, so the positive and negative root of that 25. So you're going to just bring that simple. Then if you have a negative, you want the negative root. So this is going to help you with the next page on that for what you're solving there. But now it's going to say yellow reference sheet on the next page, because typically in class I would always copy these on yellow. Any keep sheet that they need, they'd be yellow, but you won't have that. So let me do this. You may screenshot that and upload that to your Canvas. Yes, it's going to be my work. At least you want to upload your own. That's fine. It's perfect. But I want to make sure that you have that accessible to you when you need it, because you're going to refer to these cubes on the next page quite a bit. You're going to refer to this chart, and you're going to refer to this chart quite a bit. Okay? All right. That is what we talked about for the perfect cubes and perfect square reference sheet.